It's a cosine function, nothing big. It's just a cosine function. This will be plus a omega minus a omega. The acceleration should be negative. So negative sine graph, the acceleration should be. This is minus omega square a. One cycle will plot it. What do you mean by one cycle? There's a one cycle. No? What do you mean by one time period, or what is the time taken for one oscillation? Okay, fine. Huh? There's a one time period. So you write that t here. This is t, t by 2, t by 4, 3t by 4, 3t, 3t by 2. This will be 2t. That's the same thing. All of you must learn all these things. These are very important because the next after this, what happen will go for waves and so on. Almost every topic, this graph is what will be needed. Okay, we have this information. So in that spring block system, if you see this, and the block, this will be mean position, and what all form, this will possess energy. It will be in the form of, velocity and also the elastic potential energy. This is the mean position. So this is plus a, this is minus a. Like this, it will be executing the SHM. Okay, I'm showing it clearly. Okay, there's a mean position, right extreme, left extreme. So in what all form? The energy in the form of potential as well as kinetic energy, and the total energy remains constant, that we know it. So what is the expression for kinetic energy? I'm getting into the kinetic energy. Half m v square. Now what is v? A omega cos omega t whole square. M omega square a square by 2 cos square omega t. Your trigonometry should come into the picture. What happened? Pen not responding. Okay, fine. No, this is no cos square omega t. What you can write it as m omega square a square by 2 1 plus cos 2 omega t by 2. Will I agree this? There's a kinetic energy. Similarly, I want potential energy. What shall I write potential energy equal to? Potential energy is equal to kx square by 2. In fact, we know what is omega. Omega equal to k by m. So shall we write m omega square is what equal to k? Where all I want, I'll do such replacement. So shall I replace k as m omega square? Yes, k as m omega square by 2, x square a square sine square omega t. No, m omega square a square sine square omega t you can write as cos 2 omega t by 2. This is expression for the potential energy. Okay, I'm interested to plot these things also as a function of time, as a function of position, both. First, let me plot as a function of, because already the time equations I'm having. Okay, now go back to your mathematics. Okay, do you know how to plot sine square theta graph, cos square theta graph? That is what I'm asking, nothing big. Don't think that's something very big concept. The same trigonometry. Say in trigonometry, it was like a y equal to sine theta, x equal to sine theta. Here, instead of theta, you're having omega t. So bring back all the trigonometric ideas. You feel comfortable. Okay, we have to plot both kinetic energy as well as potential energy. Okay, let me take the graph now. This is energy as a function of time. We are trying to plot it here. Okay, what all we have? This is T. This is 2T, no? Okay, let me write all this one. This will be T by 4, T by 2, 3T by 4, T, 5T by 4, 3T by 2, 7T by 4, 8T by 4 will become 2T. So like this, we can continue. We can continue. So I'll show it like this, 2T. After 2T, it will be 90, 10, 5T by 2, 2.5T. Then 3T it will come. Okay, this will be 3T. Okay, we have to plot the graph. First kinetic energy. Let me plot kinetic energy. I really want students to plot such graphs because it is pure mathematics, nothing to do with physics. Sine square theta graph should not have negative off cycle. Am I right? So what you do, put t equal to 0, put t equal to t by 4, put t equal to t by 2, put t equal to 3t by 4 in this equation here. Then locate the points. Locate the points. Join all those points with a smooth curve. Then you get the required graph. No guesswork. We have to take help of this one. Put t equal to. No, if you want further, you make it t by 8. T by 8 will become half of it. So t equal to 0, t by 8, t by 4, 3t by 8, 4t by 8, 5t by 8. Or still if you want finer graph, t by 16, 2t by 16, 3t by 16, 4t by 16. This is needed. Huh? So students, they don't want like this. They want to see equation and they want to plot graph. There's a wrong thing, not possible. Huh? Tomorrow in exam, if you get equation, by seeing equation, can you plot graph? No, you have to go for again the plotting graphs method only. Okay, one thing I'm very sure, where velocity is 0, when the speed is 0, the kinetic energy must be 0. Okay, here at t by 4, what should be the kinetic energy? Should be 0. Different. At t by 2, what should be the kinetic energy? Maximum. At t by 2, it should be maximum. Again, 3t by 4, it should be 0. So therefore, the curve please try to notice the curve. So I'll go for the red and green color one. This is what? Kinetic energy. The red color is what? The kinetic energy. Okay, now we'll plot the blue color one. That will be the potential energy. Okay, how the potential energy graph will be. I'll take help of U equal to half k x square. It's a harmonic function. You are very well. I'm showing the rough plot. Okay, this is about the little bit. I think I can expand it. Yeah. So what is the blue color one? Blue color is what? The potential energy. And the red color one is what? The kinetic energy. So there's a variation. What is the maximum kinetic energy should be equal to? M omega square a square by 2. What is the maximum potential energy should be equal to? M omega square a square by 2. So therefore, what is this value? I'm going to write this as M omega square a square by 2. These are both potential energy as well as kinetic energy. This is a function of time. Now, what is one cycle? By the time block completes one to and fro motion, means it will start from here, from mean, right extreme, mean, left extreme, mean. By the time block completes one oscillation, what will happen to energy? The variation of energy, it completes two oscillation. Are you able to notice? You look at the red color one. It has completed two oscillations. I think I have to. Yeah. Okay. Well, okay. This is one cycle. We'll write it. There's a one oscillation, no? According to the block, one oscillation for the block. In one oscillation, how many cycles will be completed here? I'll use word cycle. The kinetic energy or the potential development, they will complete two cycles. If this block takes like a capital T to complete one oscillation, in that interval of time, what happen? This is the time period of variation. Okay, there's a one cycle get over. Then another cycle got in. So then look at the time period of the frequency, the kinetic energy potential variation. Shall I say half of it? Because this will become one cycle. This will become one cycle. Here, this is one cycle. For the acceleration, displacement or velocity, this is one cycle. For kinetic energy variation or potential energy variation, what will happen? By the time the block completes one oscillation, it will complete two oscillations. I would have written oscillation, but it'll get confused. That's why I'm writing two cycle. This will become one cycle. So if you look at this kinetic energy variation, if you plot only this one, no, so it will become one oscillation or one cycle it will be. So therefore, what is the time period of frequency variation? What is the time period of kinetic energy or say like the potential energy variation? It is half of it. Or shall I say, what is the frequency at which kinetic energy potential varies? Twice the oscillation frequency. If f is the frequency of oscillation of the block, what will be the frequency of kinetic energy potential energy variation? It will be 2f. This is what I'm going to conclude here. If f is the frequency of oscillation of block, if f is the frequency of oscillation of block, then the frequency of kinetic energy or potential energy variation will be 2f. I'll write it. Variation, okay, variation will be 2f. By the time block takes say like a 10 seconds to complete one cycle. By the time the block takes 10 seconds or select 10 seconds to complete one cycle. Whatever the kinetic energy, it will take 5 seconds to complete one cycle. So therefore, the frequency of the kinetic energy or potential energy variation is twice the frequency of oscillation of the block. That's what. Then the frequency of kinetic will be 2f, I'm writing. In the books open, you have twice. Okay, but it is a negative off cycle should not come. See, if you should not ask now for a physics teacher, sir, why negative off cycles are not there. Your trigonometry should be applied here. Instead of y and x, you are having u and kinetic energy. That's all, nothing big. Able to make it out. So bring back all your mathematics. The mathematics is what you should take help here. Okay, this is about the kinetic energy. So what is the average kinetic energy of a block in one cycle? Anybody? What is the average kinetic energy possessed by a block in one cycle? Zero or non-zero? We'll calculate next the next part. Okay, let's get into. So we have equations. No, I'll take help of these equations. We'll go for average potential energy or kinetic energy. Anything let it be. Okay, this is the equation what we know. Same thing once again. I'm bringing it. Okay, now what is the average kinetic energy in one cycle? One cycle means what we should take 0 to t. So how to calculate average value of a function? Can you recollect some earlier we have done? Average kinetic energy equal to Ke of t dt by dt in one cycle. So substitute this one. So this will become m omega square a square by 2 cos square omega t. Integral of dt, this will be t 0 to cos square omega t, what we have. Or I think already I'll write this equation rather than this. Already we know. Let me bring it here. Now I'll integrate. Okay, further. So let's integrate this one. So K average is equal to fine. So this is the very basic fundamentals everyone must know. Huh? This will be t, integral of dt will be t. Integral of cos 2 omega t will be how much? 1 by 2 omega. Fine. Huh? This is so now next part. This what to do? Yeah, sine of what is 2 omega? Omega is 2 pi by t, no? So this will become 4 pi t. I'll bring one more step so that will be easy for you. Huh? Let's go for limit 4 pi t. What is value of small t? Capital T, you should substitute the limit. Minus sine of okay, I think everything will end up what? The sine 4 pi will be 0, sine 0 will be 0. So finally, we'll end up with only bracket 2, 1 by 2 omega. This will be 0 minus 0. Already 1, 2 is there, no? 2, 2, and this will become 4, no? Just notice a few things. Okay, no, let's write. This is 4, 4, 4, 4, 4. TT gets eliminated. So this is the average kinetic energy of the S block executing SHM in one cycle. So what you should call this one? Average kinetic energy of spring block system in one cycle. I think this should also be equal to potential energy. Okay, this is, I think, if you are very good mathematically skilled, you would have noticed this where in the above graph only, you could have said directly what is the average value. What is there in that? So like I'll take average of this red color line. So what it will become? M omega square A square by 4 only. Getting the logic? So it will vary like this, no? So what is the average value of this red color line? Should be off of it. M omega square A square by 4. If you have some common sense, why to integrate and do so much of mathematics and to exhibit that I am very good in mathematics. If you have good common sense, huh? If you have good common sense, that is enough, no? See, that's what I want you to make observation. So this is very important. You see this one. What is the average value of this curve? Not zero. Average value of this curve will be zero. Positive off cycle, negative off cycle. Average value of this will be zero. What is the average value of potential kinetic energy? Will be half of the select half of the maximum. Maximum potential kinetic energy can be this one. Able to get this? So I ask for one full cycle. I may ask for off cycle. I may ask for quarter cycle. Okay, what should you do? So put the limits here, change the limit 0 to t by 4. Or what is the average kinetic energy possessed by particle when it moves from mean to extreme? Mean to extreme means what you should do, mean to extreme. So 1/4 of cycle, no, it will be. So these are all maths will be asked. A student must know that, okay, I'm just studying this spring block system only. In that is asking this one. Average potential energy or average kinetic energy of block in one cycle. Or potential energy also. Don't say block. Block will not potential energy. Elastic potential energy stored in the spring. Average potential energy stored in the spring in one cycle. So you can again, it will be equal to same this particular value. Okay, now this about, okay, this about the function of time. I may ask you any other questions like this. So what is the average speed in one full cycle? Zero, no? Average speed. In off cycle, S, you can find out. So what is the average speed when the particle moves from year to year? When it moves from right extreme to left extreme. I may ask you any of these things. So what you should do, there's a formula. Can you remember this? I introduced this where in the kinematics to find out the average of any quantity, not only speed. Hope if you can recollect what we discussed earlier. Okay, just see once. Shall I go for the next one? So we have the potential energy kinetic energy. Let's go for as a function of position. We'll plot it. We'll see what we'll get it here. I'll take the spring block system. Let me keep this in corner only. This is the mean position, what we have. Okay, there's a right extreme, left extreme. X equal to 0, I'll measure from here. The block is at a distance, X. Let's. So what is the expression for the potential energy of the block? And what is the expression for kinetic energy? mv square by 2. Further, v what you can write? Omega root of a square minus x square whole square. So what is the equation for this kinetic energy will be? Ke should be equal to m omega square by 2 a square minus x square. Agreed? So this is the expression for the kinetic energy. Let's plot as a function of position of the block. What is x? X I'll measure from the mean position, x equal to 0 like that. Getting the idea? This one? Okay, now let's plot the graph. I'm interested in the graph. Very important. It'll be almost will be finishing off the maximum theoretical concept of this one. No. Okay, this is the displacement plus a plus a minus a. This is 0. This is x. Okay, here I'm plotting potential energy as well as the kinetic energy. Okay, first how the kinetic energy. Kinetic energy will be maximum here. So the curve will be, because at mean position, the speed of the block. Now that, okay, this will be the, it's a parabola. I'm unable to. Okay, there's a parabola and the potential energy will be. Okay, what is this? This is the kinetic energy and this is the potential energy. What is the maximum value? How much maximum value? The maximum value is m omega square a square by 2. So how do you can say there's a maximum energy? Because what is value of maximum speed? A omega, so m omega square a square by 2 is what? The maximum oscillation energy of the system. Okay, till here. Okay, fine. So when the block is executing SHM, so when it is here, potential will be minimum at mean position. You know spring block system. Why you are thinking about SHM spring block system? So here at mean position, no compression, no elongation. What is the elastic potential of spring will be 0. So therefore, if a block executes SHM at mean position, it will have minimum potential. Better right here in the given situation it is 0. At extreme point, maximum elongation or compression, elastic potential maximum, and the block at extreme point will be at rest. So kinetic energy will be 0. Look at this kinetic energy curve. Then, is there any point where both will be equal? You can see this. Are you looking at this curve? I want you to make observation. As there is a point, I'm bringing that blue color line. I want a point where both will be equal. Shall I write a by 2? The answer is no. You can look at, see that one. X equal to 0 is what if we have and a, and it is not something a by 2 here. It is more than a by 2. Okay, I want to find out that one. So I want a point where both will be equal. Where both will be equal means the point where both will be equal. K x square by 2 m omega square a square minus x square by 2. What is k equal to? So in place of k, what I can write? M omega square x square by 2 m omega square a square by 2. So m omega square gets eliminated. So x square by 2 plus x square by 2 a square by 2, or 2x square So at what point both will be maximum? Both will be, sorry, equal at a distance of a by root 2. From where? From the mean position. X equals 0. I'll measure from mean. So somewhere here at a distance of a by root 2, now both potential energy kinetic will be maximum. How many times in one cycle potential energy will become equal to kinetic energy? 4 times potential energy will be equal to kinetic energy in one cycle or in one oscillation. The cycle, I'll take it out in one oscillation. Sir, how come 4 times? You can see that, plus a by root 2, go to extreme, then again a by root 2, mean position, a by root 2, minus a by root 2, again left extreme, again minus a by root 2, this one. So in one cycle open, 4 times will be maximum. So still I'm not understanding. Best thing is student has to draw a diagram like this. This is the best way of learning. There's a mean position. You see that one. You take help of the mathematics, what you know. That's what I'm telling this one. Take help of the diagrams here. So there's a mean position. Okay, just indicate like this. This is the plus A. Okay, plus A and minus A. No. So initially, let's assume that particle will start from here. Will go like this. Then it will come like this. No? Then again. So what is this point? X equal to 0. Where is that x equal to a by root 2? It will come here. So how many times you can see that one? So once it is moving like this, here it will have velocity. A student must have this particular SHM means will be like this. Huh? Actually, this is for your understanding purpose. Don't think that, sir, what is the time? Oh. What is the time taken for it to complete? What is the time taken by to take a turn? I think if you ask this, I should break your head. No other way. So don't say, so what is the time taken to turn? Actually, it will retrace its path. This will be much easier for you. You can see this one. Okay, 1, 2, 3, 4. 4 times the kinetic energy will become equal to potential energy. Okay, I agree this one. So this is about the initial theoretical part. What is SHM? In SHM, what happens? How things will vary? Potential energy, kinetic energy, all this are one thing. Okay, let's get into the next, the phase of SHM. Now you can ask questions of how you're writing this A sine omega t. What is the reason for this? Why don't you write cos omega t? Definitely no. Why don't cos omega t? Why you are writing sine omega t only? S is in fact. So what happened? From where you start counting the time, what happened? That will determine the equation of SHM. So for that, next topic will be the phase of SHM. You see this much. Let me have water. Okay, let's get into the phase of SHM.